right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today is another video on Algebra 1 worksheets. This one is combining like terms, as you can see here, and we're going to jump right in right now. So let me start with a color that works. I usually like to start with blue because that's my favorite color. When we combine like terms, you're kind of asking yourself two things. You're asking yourself, one, do I have the same letters, right? Do I have the same letters? Same letters, right? So you're asking yourself this question, same letters. And then, it's either yes or no. And then two, you also want to see same amount of letters. Same amount of letters. And you actually need both of those things for it to be like terms. So I'll show you an example. So same letters would be like, okay, well, like number one here. They both have the same letters. They both have K. Step two, do they have the same amount of letters? Well, yes and no. So when I say same amount of letters, I'm saying the same power of the letter, not the number in front of the letter. So it's a little tricky at first until you get the hang of it. But when you're looking at the same amount of letters, you're looking at whether it's squared or cubed or anything like that. Because if it is, then that's different from something that's to a different power. So these two are like terms. Therefore, I can put them together. So I would actually say, okay, well, what's negative 6 plus 7 then? Which means I want to subtract, since the signs are different. We talked about this in another video, right? If I have two signs and they are opposite signs, I'm going to be subtracting, so I just subtract. And it's always easiest to just subtract the biggest number into the smallest number. So I'm going to do that. 7 minus 6, that's easier than negative 6 plus 7 to think about, right? So 7 minus 6 is 1. Now, do I need to change the sign on the 1? We talked about this in another video as well. Negative 6 plus 7 is actually the same thing as 7 minus 6 because the 6 has the minus in front of it and the 7 has the plus in front of it. If there's no sign, there's a plus. So this is 1. Now, what does that have to do with negative 6k plus 7k? Well, negative 6 plus 7 is 1. And then since I'm adding and subtracting k stuff here, I put a k on it, which 1k is just k. Like if I say I have one pencil, like if you wanted to give somebody a spare pencil in class, you wouldn't be like, do you want this one pencil? You'd be like, here's a pencil, right? Now you know that you're giving them one pencil, but you don't say you're giving them one pencil. You're saying you're giving them a pencil, which is kind of what we're saying here. We're saying 1k, so it's a k. We don't need the 1. It's a k. Okay, so that's why sometimes you don't need to put the 1 there. And that was like terms, right? So to step back for just a second, the other videos that I've been mentioning so far are also on this series. So at the end of the video, there's going to be a couple things pop up. There's going to be my channel thing, and then there's also going to be a link pop up for the playlist for all of these algebra videos. And some of the ones that came out before this are the ones that I'm referring to. So if I say I'm referring to other videos, I'm referring to those videos. And if I'm referring to a video that's not on this playlist, then I'll put the link to that in the description, okay? But all the videos I'm referring to so far are videos that I've already done on this playlist. Okay, so just for future reference. Number 2, 12r minus 8 minus 12. Okay, so number 1, same letters. Well, let's see. This is an R. These don't have R's, so no, not the same letters. You have to answer yes to both of these questions to have like terms. Okay, so 12r doesn't have anything else to go with it, so it's just 12r. Now, what about these? I can kind of do the same question here. I would say same letters. Well, yeah, they both don't have any letters, so yes. And then the same amount of letters. They both have exactly 0 letters attached to them. They're both just numbers. So yes, they are like terms. All numbers are like terms, more or less. So then I say, okay, well, am I adding or subtracting? Well, the signs are the same. They're both minus signs, which means I'm adding, according to my smiley face. The face tells you whether you're actually adding or subtracting. I'm going to add them, so let's just add them. What's 8 plus 12? 8 plus 12 is 20. Now, that's positive 8 plus positive 12 equals positive 20. So if I add two negatives, remember, multiplying two negatives gives you a positive. Adding two negatives gives you a bigger negative. So it's going to be minus 20. Okay, negative 8 minus 12 is minus 20. All right, on to the next one. And if you've seen a video in this series before, you know I like to switch colors around a lot. So I'm going to do that. I'm going to switch to another shade of blue here. Now, same letters. Well, let's see. There's an N right here. And it's only got a 1 power, just N by itself. And then this is also an N. It's, technically not by itself. But what I mean by itself is, does it have a power, a little baby number to the top right of the letter? And neither of them have a visible number to the top right of them. So they have the same letters, they're both N's, and they have the same amount of letters, meaning the N's are not to different powers. They don't have different baby numbers on the top right of the letters. So they are like terms, which means we can add them. Now, if there's an N, how many N's is that? Yeah, 1, exactly. So 1 N plus 9N. 1 plus 9 is 10. So 1N plus 9N is 10N. Not 10N squared. That's a really common misconception there. When you're adding, you don't multiply the n's. So if you have n squared, it means that you were multiplying the n's. We're adding 1n plus 9n, so we get 10n. Okay, and then we have numbers. Well, numbers have the same amount of letters. They both don't have any letters, so we just put those together. They are both negative, so I'm going to add them up. 10 plus 3 is 13. Since I added 10 and 13, 10 and 3 to get 13 just now, but it was negative 10 and minus 3, I need to make it a minus. Negative 10 minus 3, signs are the same. I'm going to add and get minus 13. Okay, are these like terms? So let's see. There's an x right here. There's an x right here. So step 1, same letters? Yeah. Step 2, same amount of letters? Yes. Okay, remember when we say same amount of letters, we're talking about the baby numbers. There's no baby numbers, right? Technically, there's like a little baby 1 right there and right there. If there's no power, it's a 1 power. 1s are like ninjas. They're always there, but you never see them. So they have the same powers. So I got something in my eye there. Pulled out like 5 eyelashes just now. That was weird. Woo. Definitely had something in my eye. Okay, so if they are the same letters and the same amount of letters, then they are like terms. So we can add up the numbers in front of them. Negative 4 minus 10. I'm going to be adding those numbers up. 4 plus 10 is 14, but it's minus, and I still have the x. And that is how you do it. On to the next one. And we're changing colors as well. Okay. Are these both r's? Yes, they're both r's. Yes, they're both to the same power, so we add them up. Remember, if there's no number, it's a 1. So minus 1 minus 10. They're both minus. If the signs are the same, I add the numbers. 1 plus 10 is 11. So negative 1 minus 10 is minus 11. And then add that r on the end of there. And when I say add, sometimes I mean multiply, but I'm using add in a more non-math sense. So I'm sorry if that throws you off. Okay, x. Well, 11 does not have an x on it, but 6 does. 6 does have an x on it, so I can put those two together because they both have x. Step 1, do they have the same letters? Yes, they both have x. Step 2, do they have the same amount of letters? Yes, they both have 1x, meaning x to the first power. So negative 2 plus 6, the signs are different. If the signs are different, I subtract. 6 minus 2 is 4. Now, when I do 6 minus 2, I have to check, was the 6 positive? Yes. Was the 2 negative? Yes. So it should be positive 4x. And there's only one other number here, so that just kind of comes down, plus 11. All right, switching colors again. And let's see, so r's, okay, they both have r, and there's not different powers of r, so I put the numbers together. 11 minus 12, signs are different, so I subtract, but it makes more sense to do 12 minus 11. 12 minus 11 is 1. But since I just had to do 12 minus 11, because that makes more sense, it always makes more sense to do the big number minus the little number. But in order to do the big number minus the little number, I kind of had to switch signs. The 12 was actually the minus sign, and the 11 had the plus on it. So that means that the answer should be negative 1 with an R on it. Okay, on to the next one. That's a 1, that's a 12. They have different signs. They are like terms. They both have V's, and they don't have different powers of V. So I put the numbers together. The signs are different, so I subtract. 12 minus 1 is 11. The 12 was already positive. The 1 was already negative, so we're good to go there. 11 and V. All right, changing colors. Negative 8x minus 11x. They both have x. There's not different powers of x, so they are like terms. We can put them together. Negative 8 minus 11. Signs are the same, so I add. 8 plus 11 is 19. Since they're actually both negative, it's going to be negative 19 and x. 4p plus 2p. This one's a pretty simple one. They both have p. There's not different powers of p. I can add the numbers. So 4 plus 2 is 6. And I tack on that p there. All right. Now we're on to yellow. Ooh, go back to draw. There we go. And here we go. So 5n plus 11n, they both have n. Not different powers of n. 5 plus 11 is 16. And n. Boom. This one's got a few things on it. Here's an n. 4 and 9 don't have n on them, so we cannot add those to n. They're not like terms. But this one has an n. They both have n, and the n's are not to different powers, so I can add the numbers. That's 1. Remember, if there's no number, it's a 1. 1 minus 5, signs are different, so I subtract. Always subtract the big number into the littler number. But I had to switch the signs to do it this time. 5 minus 1 is 4. That's the easy way to subtract, is big number minus little number. But in order to do that, I had to switch because the 5 was actually minus, the 1 was actually plus. So this should be minus 4n. Then I've got two numbers here, and they have different signs. So I want to subtract. 9 minus 4 is 5. Did I have to switch the signs? Yes. The 9 was minus. The 4 was plus. So this should be minus 5. Okay, that's what I'm doing. Here's an R. Here's an R. They both have the same power of R, so 12 plus 3 is 15. Here's a 5. Here's a 5. Oh, hey, 5 minus 5. That goes away. That's 0. So it's just 15R. There's only one n here, so it can't combine with anything else. 9n. Okay, but there's two numbers, negative 5 plus 6. The signs are different, so I subtract. 6 minus 5 is 1. Did I have to switch the signs? No. 6 is plus, 5 is minus, so we're good to go. It's a plus 1. All right, we are on the second half already. That's fast. Let's take a preview of what's to come here. Ooh, got some crazy stuff going on. Got some distributive property right here, and then we'll be combining like terms down towards the end there. So let's go ahead and look here. So n, no other n's. Minus 4, minus 9, same sign, so I add. 9 plus 4 is 13. I had to switch the sign, so it's minus 13. 4n minus n. Careful, remember that's a 1. So whenever you minus, the n does not go away. It wouldn't be 4. 4n minus n is not 4. It's 4n minus 1n. It would be like if n was the amount of pencils you have in a pencil pouch. If you have 4 pencils in your pencil pouch and you give one away, you have 3 pencils left. So the n does not go away. I see that a lot. It's a common mistake. 4n minus n is 4n minus 1n. So 4 minus 1 is, I almost said 4 minus 1 is 1. 4 minus 1 is 3n. And there we go. Okay. On to the next one. I think that's like a blood orange. Okay. X, negative 3 plus 15. Those are different signs, so I subtract. 15 minus 3 is 12. Did I have to switch the signs? No, It's plus 15 minus 3. Okay, cool. So 12x. And there's only one number. So that just comes right down. All right, these are like terms. They both have k, not different powers of k. Negative 9 plus 8. Signs are different, so I subtract. 9 minus 8 is 1. But I had to switch the signs in order to do it that way. So it's going to be minus 1. Okay. And when it's minus, you can actually leave the 1 in usually. Or you could just write it as negative k. I think either one would be fine. They usually don't like it when you write 1k. But I think negative 1k is fine with some teachers. Just depends on who your teacher is. So, all right, 19 and 20. These are like terms. They have the same letter and the same amount of letters. Negative 16 minus 14. The signs are the same, so I add. 6 plus 4 is 10. Carry a 1. 1, 1, 1. That's 3. And it's going to be negative 30 because I had to subtract, I'm adding two negatives, or you could say negative 16 minus 14. But since the signs are the same, I end up adding and getting a bigger negative number. And then, of course, in there, right there. Those are like terms. I'm going to subtract. 19 minus 15 is 4. But I had to switch the signs, so it's going to be negative 4n. All right, next one. This time we've got some distributing. We're on the latter half here, and we've only got a few more, 10 more, I believe. 10 more and we're done here. Okay, so let's go ahead and do this. So if you do have to distribute, you want to do that first because distributing is multiply. Combining like terms is adding and subtracting. So remember PEMDAS? Please excuse my dear Aunt Sally because she farted. So please excuse my dear Aunt Sally. You would do parentheses first, but there's nothing to do inside the parentheses. 1 minus 3m. I can't actually subtract those because they're not like terms. So I wouldn't do parentheses. There's no exponents. So multiply. Distributing using the distributive property is multiplying. Okay, so that's why we have to do multiply first. We have to do distributing first before we can try to combine like terms. So negative 4, that just comes down. 7 times 1 is 7. 7 times negative 3, this is a positive 7 times a negative 3. So we're kind of switching gears here. Careful, we're switching gears. We want to multiply a positive and a negative. So we get a negative. Multiply a positive 7 and a negative 3. So we get a negative. 7 times 3 is 21. And there's an m right here. Whew. Okay, so we just distributed. And then we look for like terms. This does not have a like term. There's only one thing with m in it. But there's two numbers here. They have different signs, so I subtract. 7 minus 4 is 3. I didn't have to switch the signs to do that. 7's positive, 4's minus already, so it's going to be plus 3. And I'll start boxing my answer from here on out because we're going to do a little bit more work to get to these answers. All right, let's do it again. So we want to distribute first. Oh, by the way, this was multiplied, so this was distributing right here. Then I was adding and subtracting. So I didn't have any division to do either. Okay, so distribute first, then combine like terms. Negative 5n, that's 3 times 6 is 18. 3 times 7 is 21. I'm not worrying about the signs because there's no negative signs, right? So 21n, by the way, because there's an n right there. 3 times 7. N is 21n. Okay, and then we look for like terms. Here's some like terms. They both have n, and they don't have different powers of n. So I want to subtract. You always do the big number minus the little number. Okay, and that should be 16. Did I have to switch the signs? No. Negative 5 plus 21 is actually the same thing as 21 minus 5 because the signs in front of the numbers did not change. So 16n, and there's only one 18. So plus 18. Final answer, box it in, lock it in. And let's just start here, I guess, and go forward. The other side of blue. So we want to distribute. Be careful when there's only a minus sign. Remember, you're still distributing something. And ones are like ninjas. They're everywhere. So boom, there's a 1 right there. So negative 2n. Negative 1 times 9. Well, it's going to be minus because a negative times a positive is a negative. It's a positive 9. And then 1 times 9 is 9. Okay. Negative 1 times negative 10. Negative times a negative is a positive. 1 times 10 is 10. And n. And here's some like terms. So now that we're done distributing, we can do like terms. That's going to be a minus. I'm going to be subtracting negative 2 plus 10. I'm ignoring the negative 9 in between them. Negative 2n plus 10n. I'm ignoring that minus 9 in between them, because you can add up numbers however you want, as long as you keep the minus sign in front of the numbers that have the minus signs. So we're subtracting because the signs are different. 10 minus 2 is 8. I didn't have to switch the signs to do that, so it's 8n minus 9. Final answer, lock it in. All right, we're distributing. 10 minus 5. It's going to be minus because it's negative 5 times positive 9, which is a negative. Negative times a positive is a negative. I'll rewrite the smiley faces over here off to the side. Right, so when I'm multiplying and dividing, the face, either happy face or sad face, represents the sign of the answer when I'm multiplying or dividing. When I'm adding and subtracting, I can use the same set of faces here to tell me whether I'm actually going to be adding or subtracting. So the eyes mean the same thing, but the mouths mean something different whether you're adding, subtracting, multiplying, dividing. So anyways, 5 times 9 is 45. In, can't forget that in. And then negative times a negative is a positive. 5 times 9 again is 45. Okay? And then we've got some like terms. This is not a like term with anything else, that is. Doesn't have any other ends. There's no other ends, but there's a 10 and a 45. They're both positive. I just add them up. 10 plus 45 is 55. All right. So up next we have, let's see, got seis más problemas we want to distribute. So 9a plus 60a minus 10. Okay, 10 times 6 is 60, 10 times negative 1 is negative 10. Then I want to see if I can combine like terms, and I can. There are two a's, so 9 plus 60 is 69a, minus 10 is the leftover little bit. That didn't combine with anything else. Ooh, now we've got to distribute twice. Oof, all right. Gotta do that. Negative times a positive is a negative. 9 times 6 is 54. Add that in, or sorry, m onto the end there. Negative times a negative is a positive. 9 times 3 is 27. And we're done distributing that one. Now we distribute the other one. 6 times 1 is 6. 6 times 4 is 24. With an m. Okay, so we've got two m's. The signs are different, so I subtract. It's going to be 54 minus 24. Remember, always subtract the big into the little. 54 minus 24 is 30. It's kind of a weird zero, sorry. But I had to change the signs that time. The 54 was actually the negative, not the 24. So since I switched the signs, I switched the sign of my answer. So it's negative 30 m. And then I've got two positive numbers here. So I'm just going to add those up. And I would get 34. All right. Actually, I don't get 34. Sorry, I get 33. I mathed wrong. 33. All right. Plus 33. And we're on to the next one. Ooh, like a peach. That's probably going to be hard to see, so I'm going to increase the thickness just a little bit. Let's see here. Yeah, it's not too bad. You can see that, right? Let me know in the comments if it's hard to see this when it actually goes to post. So negative times a positive is a negative. 10 times 1 is 10. Negative times a negative is a positive. 10 times 9 is 90 with that x. 6 times x is 6x. Positive 6 times negative 10. Positive times a negative is a negative. 6 times 10 is 60. Here's our like terms for the x's. 90 plus 6 is 96. X. And then I've got two numbers. and they're both negative, so I add them. 60 plus 10 is 70, but it's minus 70 because I added up two negative numbers to get a bigger negative number. All right, we've got a little bit of distributing to do here as well. Positive times a negative is a negative. 5 times 2 is 10. N. 5 times 4 is 20. 2 times n is 2n. 2 times 3 is 6. All right, here's my n's. Negative 10n plus 2n. I'm going to subtract. That would be 8, but the 10 was negative, the 2 was positive, so I need to make this negative 8n. 20 plus 6 is 26. All right, on to the next one. And let's decrease the thickness back down to where it was. Okay, so distribute, 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 distribute. Negative times a positive is a negative. 3 times 10 is 30. And a b. Negative times a positive is a negative. 3 times 10 is 30. 5 times b is 5b. 5 times 2 is 10. Okay, like term, like term. They both have the b thing in them. Negative 30 plus 5. I'm going to be subtracting. The signs are different. 30 minus 5 is 25. But the 30 was negative, the 5 was positive, so this is going to be a negative 25b. Then I've got two of these guys. The signs are different, so I subtract. 30 minus 10 is 20, so this would be negative 20. All right, last but not least, distribute, 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 distribute. Negative times a positive is a negative. Negative 7n. Negative times a positive is a negative. 7 times 3 is 21. Negative times a positive is a negative. 8 times 1 is 8. Negative times a positive is a negative. 8 times 8 is 64. And n. Okay. And oh, just got yelled at by my computer to give it some juice. Let me go ahead and put my charger cord on here. There we go. There you go, buddy. Okay, so we want to go ahead and put our like terms together. Those are both negative, so I'm going to add them. 64 plus 7. They're both negative, so I'm going to add negative and a negative. I'm going to add them up. All right? I'm not multiplying anymore, so I don't follow the rules of multiplying and dividing negative and positives. 7 plus 4 is 11. 6 plus 1 is 7. I had to add two negative numbers, though, so I should have a bigger negative number. Negative 71n. And I've got another two negative numbers here that I add. 21 plus 8 is 29, so that's minus 29. And you know what I just realized? I have not been boxing in my answers. I said I was going to box in my answers, but I wasn't. So you know what? It's fine. It's fine. Totally fine. Here's the answers that they have. Just the answers by themselves. And as always, I challenge you to see if I made a mistake somewhere. If you see a mistake somewhere, let me know in the comments. Because I almost did. I almost did make a mistake because I think I put 34 there for one of them instead of 33. Okay, so there's the answers, but that's not all I'm here to do. I'm here to show you the solution, the whole thing, step-by-step directions on how to solve these things, okay? So that is all for this video. If you haven't already gotten my awesome free guide, it's the 5 math mistakes everyone makes and how to avoid them. It's free on my website, myersmathematics.com. And this video is part of a series on videos. You're going to see somewhere around me and the screen here, it should pop up actually down below, the video, the link to the playlist and the link to my channel and things like that. So go ahead and take a browse and see if anything else is helpful to you. And I hope it is. And I hope you have an awesome, awesome